Section 1 was solving one-step equations. Section 2 is solving two-step equations. Section 3 is what we call solving multi-step equations. That means you might have 3 or more steps that you have to follow in order to solve the equation. Maybe 2. I guess 2 would be multi-step as well, but basically what we're talking about is 3 or more. Equations that are more complicated than just subtracting from both sides and then dividing by a number, okay? To solve multi-step equations, these 4 steps right here are like gold to you. Eventually you get to the point where you just have them memorized, and solving multi-step equations will seem as natural as breathing, as long as you are actually doing the problems. So, after each step, and really before you even begin, look for like terms to combine. Combine like terms is always like the first thing you start off with. I'm going to actually put that here. Even before you begin, look for like terms. If you see like terms you can combine, then combine them. It'll make life easier and avoid a common mistake that people make. Next, your goal is to get the variable on one side of the equation and all of the other stuff, all the numbers on the other side of the equation. It doesn't matter which side the variable's on. Pick one. I usually like to go with whatever's going to make my variable positive. Doesn't matter to me which side I go to. You're always working to isolate the variable term. We talked about that yesterday, last time in section 2. You want to get the variable term by itself. Save that division or multiplication to get that variable to a 1. Save that for last. Okay, so I'm going to put that again here. Save the division till last. Too many times people try to divide the number in front of the variable immediately, and that just leads to mistakes. Use the properties of equality to keep the equation balanced. That's just like a obvious no-brainer there. That's how we're going to get the variable on one side and all the other stuff on the other. We have to use the properties of equality. So those are the 4 steps you're going to be following. Not necessarily in that order every single time, but that's the idea. So let's take a look at this first example then. 5 equals 5m minus 23 plus 2m. The first thing I want to do is take a look at the equation to see if I can combine like terms. All right? Step back. Don't just start plowing ahead in a problem. Try to understand what the problem is trying to get you to do, okay? Look at it. We have a number on one side, and we have a bunch of stuff, including our variable, on the other side. So since I already have all of my m's on one side, this is the side I'm going to keep my m on, and I'm going to try to get my numbers all over here. Okay? So that's my goal. Now if I take a look at the right-hand side, since there really isn't a whole lot to do with the left-hand side, is there anything I can see to make my life a little bit easier right now? Yes, combine like terms. The 5m and that positive 2m are like terms. We can combine them. What do we get when we combine them? 7m, right? That's a positive 5m and a positive 2m. Those get put together to give me a 7m. So 5 equals 7m, and then that minus 23. We didn't do anything to that, so that just sticks around. Notice that now that I've combined like terms, I'm really back in section 2. I have a 2-step equation to solve. What's the first thing I need to do? Yeah, we want to undo subtract 23 from the variable term. We want that by itself, so we're going to add 23 to both sides. On the left side I get 28 equals 7m, and that negative 23 plus 23 turns into 0. It's gone. That was the whole point of doing that. And now we're 1 step away. We're back in section 1. What do we do to solve this? Divide by 7. Notice we're saving that division for last here. We get what on the left? 4 equals 1m, or just m. There's your answer. So as we work our way through these problems, it's kind of like we're starting off in section 3, and then very quickly we wind up in section 2, and then back in section 1, and then we have our answer, okay? So like I keep saying, your ability to do this chapter depends on every section in this chapter. You need to know how to do section 1. You need to know how to do section 2. Now you're going to need to know how to do section 3. Next problem, 11y minus 8 minus 6m equals 22. We actually can't solve this one. There's a typo here. This should be a y. Probably as I was making that, I just copied and pasted it and forgot to change the m from the previous problem. All right, now we can solve this one. What do we do? We have like terms to combine. The like terms are 11y and negative 6y. So when I put those together, what do I get? We are adding these two things together. I have 11 y's, and then I have negative 6 y's. So I get 5y. We are combining them, which means we are adding them. But that is a positive 11 and a negative 6. So it behaves like subtraction. 5y. And then what? Minus 8 equals 22. Okay, so that was the section 3 part, and now we're back in section 2. What do we do? Add 8 to both sides, and we get equals 30, and now what? Yep, divide both sides by 5. We're in section 1 right now. Y equals 6. Technically, 5 divided by 5 is 1, so there's a 1 in front of that y. You don't have to write the 1 in front of the y, it's just y. Anytime you have a variable with a no number in front of it, we understand that to be a 1. All right, go ahead and try the next two. There are no typos in that one, so you can solve these two problems. All right, we see like terms here. We have, what are my like terms? The negative 2y and the 5y. Those will combine to give me 3y. Finish off the equation. Okay, now what? Subtract 5 from both sides, and we get equals 9, nice, and divide by 3, y equals 3. Now, let's say this is an even problem in the book. What should we do? Plug it in. Take the 3, plug it in up here. What do we get here for this term? Negative 6. What do we get for this term? 15. So we have negative 6 plus 5, which is negative 1 plus 15, which is 14. So we get 14 equals 14. This is the correct answer. All right? I'll even say, let's say that's an odd problem. What should we do? Please, look in the back of the book. Or just check it yourself, okay? But check these problems. Don't be turning in homework that has wrong answers. You can make every single answer right just by checking. Okay, what do we do first on that one? And what do we get when we combine like terms? 2x. We have an 8x and a negative 6x. Those combine to give me 2x. It's like I have $8 and then I spend $6. Now I have $2. Okay? Plus 5 equals 25. What happens now? Subtract 5 from both sides, and I get equals 20. So then I'm going to divide both sides by 2 to get x by itself. X equals 10. And now we're going to check. So this first term becomes 80. 80 plus 5 is 85. This guy becomes negative 60. So we have 85 minus 60, which is, so it works. Circle your answer and move on. All right, another type of problem that we can throw at you in this section is a problem like this. What is this problem telling you to do? Yes, you're doing the distributive property here. So we have parentheses, grouping symbols, and then out front that negative 8 is doing what to that grouping symbol? It's multiplying. That means distributive property, okay? So once you distribute, you will then combine like terms and then solve the equation. So if I distribute here, I have negative 8 times 2x, which is negative 16x. And then don't forget the second term, plus 8 equals 36. Now, what do we do after we distribute always? Look for like terms to combine. On the right-hand side, left-hand side where we just distributed, do we have any like terms to combine? No. So then we can proceed from there, okay? But get in that habit. Anytime you distribute, always look for like terms. So how do I solve this one now? Subtract 8 from both sides, because currently we have 8 being added to that variable term, so we subtract 8 from both sides. What do I get? Okay, 28 over here equals negative 16x on the left. Now what? Divide both sides by negative 16. Good. Glad you caught that. So what do I get on the left? X equals what? We're dividing. It is going to be negative. (28) divided by 16. I don't want a decimal. It is negative. We don't need a mixed number. What are we trying to do to this thing? What is this? It's a fraction. What do we do to fractions? We reduce them. This is just a fraction that needs to be reduced. What is the greatest common factor of 28 and 16? 4. So 28 divided by 4 is, and 16 divided by 4 is, negative 7/4 is your answer. On a calculator, on our calculators, you could type in 28 divided by negative 16 and it will give you the answer of negative 7/4. It'll even show exactly what you see here. You believe me? Let me go to my calculator and I'm going to type in 28 divided by negative 16, enter, negative 7/4. It gives you the fraction reduced. No more excuses for not reducing fractions. Reduce the fractions though. Use your head. Try not to use the calculator. Don't rely on the calculator for that. So, second problem, what should we do? Distribute. What will I write? Oh, I heard somebody say 6. It's not 6. You got to distribute to both terms. We're multiplying 3 times 2x. We're also multiplying 3 times negative 6. Okay. Distributive properties over. What do we do now? Combine like terms. Do we have any like terms to combine? No. We will eventually. Now what? Okay, add 18 to both sides. What do we get? All right, now what? So we get 6 equals x is our answer. Again, check your answers. Make sure you're getting these right. I do want to point something out here. In early level math classes, typically you get answers that are nice numbers. Everybody's happy to see a 6. Nobody's really happy to see a negative 7/4, right? You kind of cringe. Don't cringe. Just because you get a fraction doesn't mean that it's wrong. It might be wrong because typically in Algebra 1 you do see nice, easy numbers. But this one is not, okay? So just because you see a fraction doesn't mean it's bad or wrong. Go ahead and do the next two. Third problem, what do we do? Distribute, so go ahead. Go ahead. Yes? Good. Okay. Do you want to keep going? Okay, what do we do next? All right, so this is a common mistake here because typically, like up here, we were adding 8. You see a plus 8, right? so we are adding 8 here, so we're going to have to subtract 8 from both sides, right? Here we see that minus 12x sitting there, so the common mistake is to say, well, I need to undo that minus by adding. But that's not what happens. This is a positive 36, and we want to get that to disappear, okay? So in order to get the positive 36 to disappear, I have to subtract 36 from both sides, okay? Minus 36, minus 36. That is a very common mistake, and I've seen a couple of people do that so far. 36 minus 36 is 0. I'm left with negative 12x. I've seen a couple of people make that mistake also. The sign goes with the number. That is a negative 12x, so you need to make sure you write down negative 12x equals. Okay, 60 minus 36 is 24. All right, you want to redeem yourself? What do we do? Divide by negative 12, good. Okay, so on the left side we get x equals, this is a positive 24 divided by negative 12. Positive divided by negative is negative 2. And then we should, this is super easy to check, negative 2. We have 3 minus negative 2, which turns into 3 plus 2, which is 5. And then 12 times 5 is 60. So that is the correct answer. All right, somebody else. What do we want to do first? Somebody else? Volunteer? We're just calling somebody. Go ahead. Okay, distribute. What do we get? Nice. Okay. Remember that gets distributed to both terms. You want to continue? Okay. Good. This is a negative 18. We want that to turn into 0, so we're going to add 18 to both sides. And now what do we have? 24 plus 18 is 42. Now what? Divide both sides by that negative 6. X equals negative 7. 42 divided by 6 is 7, but that's a positive divided by a negative, which is negative. So we get a negative 7 as our answer. And we can check that pretty easily. Negative 7 times 3 would be negative 21 plus 9 would be negative 21 plus 9. You owe me $21. You pay me back $9. How much do you owe me? $12. So that means this is negative 12 times negative 2, which is positive 24. So that's the right answer. Got a whole page of fractions here. Looks fun, right? No? Not really? What do we need to do if we're going to add or subtract fractions? Because that's what's going on here, right? We got a fraction minus a fraction. We got a fraction minus a fraction. We got a fraction plus a fraction, and so on. What do we need to do? Yeah. Huh? I like it. We have an x in this term and an x in this term. These are like terms, so you can combine these. How can I combine these two terms? We'll need a common denominator. Take a look at this one. Are these also like terms? How will we combine those? We'll need a common denominator. Take a look at this one. Are these like terms? No. So can we combine them? No. That means I need to get the variable term here by itself. Take a look at this one. Are these like terms? Yes, they both have an x in the numerator, okay? So they are like terms. We can combine them by making a common denominator. So there's two ways to solve these problems. With common denominators, and then muddle your way through the fractions. Or you figure out what the common denominator is going to be, and then you multiply the entire equation times that number. What that'll do is that'll get rid of the fractions for you. Which way sounds better? We don't know. Get rid of the fractions? Maybe we'll deal with that later. All right, I need a common denominator for 4 and 3. I don't want that. Go away. 4 and 3 is 12. So what do I need to do to this fraction to make 12? What's that? Yeah, I got to do 4 times 3 to get 12, so I need to multiply the top times 3. What is 3 times 3x? 9x. Okay, what do I do to this 3 to get 12? Multiply by 4. So that means my numerator will become 4 times the numerator, which is 4 times x, or just 4x. Now we have a common denominator. It's no big deal. We've done this before. You've been doing this since like 5th grade, 6th grade maybe. So now there's a letter involved. So now we have common denominators here. Can we combine those like terms? What do we get when we combine those? 9x minus 4x. 9 apples minus 4 apples. Yes. 5x over 12 equals 10. Now, you could do this in 2 moves. You could also do this in 1 move. Think back to section 1. What could we do here for 1 move? Go ahead. Multiply by the reciprocal, which in this case would be 12 over 5. This says 5/12. So if we multiply both sides by 12/5, 12/5 times 5/12 will become, not 0, 1. And we'll just be left with x equals, on this side we need to multiply by the same thing. 120 over 5. Yeah, you always reduce. That's a fraction that we have to reduce. Is 120 divisible by 5? Yes, because you see a 0 at the end. So that means we're going to get a nice number as our answer. What is 120 divided by 5? 14? 23?
No, 24.
Well, if you think about it, what's 100 divided by 5?
20.
So it's got to be over 20, right? It's 24. X equals 24 would be the answer there. Okay? I'd like you to try the second one on your own. 2b over 5 plus 3b over 4 equals 3. Go for it. So what do I need to do first on this problem? Need a common denominator because we have like terms sitting here. So I want to combine those. My common denominator here will be 20. So I'm going to write over 20 plus over 20 equals 3. What do I do to 5 to get to 20? Multiply by 4. So that I got to do the same to the numerator, which will give me 8b. What do I need to do to 4 to get to 20? Multiply by 5, so my new numerator will become 15b. Okay, now we can combine like terms. What do we get? (23b) over 20, right? Equals 3. Okay, now what can we do? Multiply by the reciprocal. We got 23/20ths here. So if I multiply by 20/23 to both sides, it's a really weird number, but it works. This becomes what? Not 0, 1b, or just b, equals 60 over 23. Does that reduce? It does? No, it doesn't. You can type that into your calculator, 60 divided by 23, and hit enter, and it'll give you 60/23 as the answer. It automatically reduces the fraction for you. So if you're trying to reduce a fraction, you can do that. Circle it. You're done. That's the answer. You should check it in the back of the book. Hopefully it's an odd problem. Otherwise, though, you should check it. Okay? Just because it's ugly doesn't mean don't check it. Actually, because it's ugly, check it, because this could be wrong. A weird number like this, usually in Algebra 1, that means it's wrong. But in this case, no, it's right. Next one. The other x terms, this guy here, the last one on the page. What should we do? Okay, combine like terms, because we have 2 terms here that are like terms. So in order to do that, I will need to. Common denominators here will be You could go 32, but 8 actually works, right? Because 4 goes into 8. Try to look for the smallest common denominator. What do I need to do to the first term to get that common denominator? Multiply by 2. So the top will become 6x. What do I need to do to the second guy? Nothing. So it stays x equals 5. Way easier numbers than 32, for sure. So what do we get on the left now? What does that say? What are we doing here? We're combining like terms, right? So what will my denominator be when I combine them? Okay. Now we just got to worry about this. What does that say? That 6x minus 1x is 5x. Remember there's a 1 there, okay? It's not 6x minus x becomes just the number 6. It's 6x minus 1x becomes 5x. Over 8 equals 5. So now what do? Multiply both sides times the reciprocal. 8/5. 8/5. What do we get on the left? 40 over 40x, which is 1x, which is just x, equals, it's 8, yeah. Notice we have 5 times something divided by 5, right? We had that happen last time. That means these 5s form a fancy 1. They're out of there, and I just have that 8. Actually, fairly easy math right there. X equals 8. All right, I saved this one for last because I want to show you guys something. I've been telling you that the calculator will do fractions, right? Well, it'll also do fraction math for you. What do we need to do to this equation? We don't. These are not like terms, right? We can't combine these. They're not like terms. I don't see an m sitting here. So, hang on. Think back to what we were doing before. If I can't get m by itself right now, what do I need to get by itself? The term. This guy right here needs to be by itself. That means I got to get rid of that 5/6. So I will do what? Subtract 5/6 from both sides. Now what is 1/9 minus 5/6? What will we do? We need a common denominator, but what we're going to do instead is this. We have 1/9 minus 5/6. We're going to enter that into the calculator. On your calculator, you have a little button above the division symbol. Looks like a box over a box. To get to anything that's above the button that you're looking at, you press Control first. So I'm going to press Control and that division symbol, and it gives me a fraction template. So now I'm going to enter in my 1/9. 1 on the numerator, press down, and that gives me the denominator, 1/9. Press to the right, and that exits you out of that fraction template. Then type minus. Not negative, minus. There's a difference. That one's the minus. Then do it again. Control, fraction template, 5 divided by, oops, I went the wrong way. Let me go back in, down, there we go. Divided by 6. Does that not say 1/9 minus 5/6? It does. Press enter. Calculator does the math for you. It's negative 13/18. Okay? You don't need to find a common denominator there. So now I can come over here and I can write negative 13/18 equals what? Negative m over 3. Now I need to get m by itself. I want m. Multiply by, not just 3, I want m. If I multiply both sides times 3, it gives me negative m. So I need to multiply both sides by negative 3. On the right-hand side, what do I get? On the right. Just m equals. And now I just need to do 3 times negative 13/18. Let me go back to my calculator. I already have negative 13/18 sitting right here, right? So just hit times. Notice it says ANS. What's ANS stand for? Answer. That means my last answer that I got, which is right here, times what? Negative 3. And the negative button is that guy. 3. Hit enter, and it gives me my answer, 13.6. All right. Now, is the calculator nice? Yes. Does it give me an answer when I'm working with fractions? Yes. Do I still need to show work? Absolutely. Okay. The calculator helps me work through those fractions a little bit easier. The process is still the same. So see what the problem has. Don't get bogged down by the fractions. We still had get this thing out of there, get the variable term by itself, and then finally get the variable by itself. It's the same process. Now we're given decimals. Now your answer can be in decimal form. If you're given fractions, your answer must be in fraction form. Okay? Working with decimals is just like working with any other numbers, even fractions. The process to solve the equation is still the same. So, if you look at this first problem right here, what do we need to do first? Get the variable term by itself. This is the variable term, which means we need to get rid of this positive 3.5. How do I get rid of positive 3.5? Subtract 3.5 from both sides. Do we know how to add and subtract decimals? We do? You want to line the decimal up, right? Okay, did I line the decimal up here? Nope. Terrible. So I'm going to erase that, and I'm going to try again. Line up the decimal. Minus 3.5. Now what? Subtract. So that's actually 3.50. 4 minus 0 is 4. And then I have to borrow here. Okay, that becomes 7. The decimal point comes down. Now what? 0 minus 3 is negative 3.74. Everybody agree with that? Yeah? No? How could we check to see if this is right? Okay, use the calculator. Bring up the calculator. We have 1.24, and then we're minusing 3.5. Hit enter, and you get but that's not what I got over there. Who is right? That's a good question. Who's smarter? Who's smarter here? Usually the person is smarter than the calculator. But actually in this case, the calculator did the work correctly. This is the right answer. The reason why is when we have two numbers with opposite signs, what do we do? What's the procedure? We figure out which number is bigger, right? Which number is bigger? Which number is bigger, 1.24 or 3.5? 3.5 is bigger. Then we take away the smaller number from it and we keep the sign of the bigger number. So our answer will be negative, but we need to do 3.50 minus 1.24. Now when we do that, we borrow and we get 6, 2.2. So our answer actually is negative 2.26, just like what the calculator gave me. Okay? So the lesson to learn here is remember what I taught you when it comes to subtracting things with opposite signs. And then you must figure out how to do that subtraction correctly. Or what? Okay, or you'll get the wrong answer. But the alternative to doing that would be to type it into your calculator. Type it into your calculator. Okay? That's what they're for. Use the calculator to come up with that answer. So, show your work. Yes. Do the subtraction on your calculator. Write down the answer. So now on the left-hand side we have negative 0.02x equals negative 2.26. What do we need to do to get x by itself? Divide by negative 0.02 to both sides. How should I do that? On the calculator. I have the, come on. I have the negative 2.26 already sitting there, so what should I type? divide by negative 0.02. Enter. And I get x equals 113. What? I do something wrong? That's what I got. No, my decimal's over here. I get 113. Negative 2.26 divided by negative 0.02. What did you get? It's 113. You typed something in wrong if you didn't get 113. Be very careful with these decimal problems, okay? I normally don't say rely on the calculator, but use the calculator, but make sure you type stuff in correctly. So on this one, what should we do? Good. Plus 2.325 to both sides. Now this time there is no subtraction going on, so you're not going to make that mistake of subtracting the wrong thing. On the left side we get what? Equals? Nope. Not 5. It's not 1. 6.275? Okay. Now what? Divide by 0.5. And what happens when we divide both sides by 0.5? What do we get? 12.55? There you go. That's your answer. Now, I'm still showing work, right? I'm using my calculator, but I'm still showing work. I still expect to see this stuff. Got it? All right. Let's work through this one. What should we do? Minus 2.3 to both sides. There's no confusion on the subtraction here. I could actually do that in my head. What do I get on the left? Negative 0.05 x equals positive 2.5. That's a positive 4.8 minus 2.3. Positive 2.5. Now what? Divide by negative 0.05. Watch those negative signs. And we get x equals what? Negative 500? Negative 50. Okay? It is negative, and it is 50, apparently. Although I don't really believe that. 2.35? 2.45. I don't think so. We better check this. 2.5 divided by negative, so I'll go 2.5 divided by negative 0.05, enter. It's negative 50. And one more, quickly. What do we do? Subtract 2.4 from both sides. When I do that, 1.2 minus 2.4 would be negative 1.2 equals negative 0.6x. Divide by negative 0.6. And when we do that, what do we get? X equals, louder, positive something. Negative divided by negative is positive. Two? 0.2. I think it's 2. There you go.